inside your object. So a typical sensor network there, collection of nodes. You've made up your own nodes, but they're the things that you're developing in the labs, as I say, and some sort of gateway to the internet, whether it's a router or something to switch that it's sort of working through to sort of get there. This communication is essentially dealing with getting some data, point A to point B, and possibly routing it through a series of them. I may want to get a message up to, again, the sort of top corner over there, and I can write it down on a bit of paper and say, okay, well, here's a message, I'll just write it on this bit of paper. Can you just make sure that gets up to the back up there, please? So it can go a load of different routes. The message may get passed along the front here and then sort of back up the side. It may go to the top, it may go up and down, work its way there or whatever. There's various ways that method can get through. That's down to both the topology and some sort of routing one. We're basically we're providing a solution for end-to-end packet delivery of this data from a source to a destination. They may not be within radio range. So it may be that I'm trying to get something to a far off place and I can't transmit that far, so I have to rely on people in between, on intermediate nodes to forward it, making it this distributed system. And it's generally down to software to do this. And this occurs all over the place, whether it's wireless sensor networks, which is essentially what we're often dealing with, or things like networks in cars, vehicle-based networks, where you've got cars with sensors and they need to transmit on, and they're picking up retransmitters at different places. You have that sort of thing with your mobile phone. You're constantly moving across from one transmitter to another one, and hopefully getting seamless communication between you and your person that you're talking to. Different sort of types of networks are basically going on there, but your main concern is it's got to be reliable. If I say, here's this data to send, it's got to get there. It's got to be reliable. And how fast does it get there? It should hopefully get there, within an acceptable time. It's not going to be saying, here's a message, turn off the lights in 5 minutes, and it gets there an hour later. It's got to get there within an acceptable time, and it's got to be reliable to sort of make it. The network module, some of its other roles, it's responsible for sending these packets. Got to decide how big a packet can you transmit at once to get there. And I'll keep using these analogies of everyday sort of conversation. I could say, here's a message to give to that top left corner, and I spend 10 minutes telling you what the message is. There's no way you're going to remember a 10-minute message to retransmit it. It's better I would say, here's the first sentence, pass that on. Here's the second sentence, pass that on. So you get an acceptable packet size at the other end. And at the other end, you've then got to perhaps piece together that full message out of all the individual components. So a packet, you need to, part of the management of the network, involves deciding how big these packet sizes of data are, and what format they should be in, how to address where to get to it. Go to the 10th row, 8th person along, or go to seat number 868. There's different ways of addressing where to get to it, and how people understand those addresses. How the nodes come in and leave. You see, with one of the problems being power supply, some of these transmission nodes may just drop out. And if you're relying on that to send data over, it's a bit of a problem for it. So there's quite a few issues to look about, where you're trying to get a message from one node across to another, which is typically sort of out of range. Some common techniques that they use, there's one called flooding, which is very wasteful on bandwidth, but it entails me saying, right, I want to get a message to Sue in the back row. I'm sorry, there's no Sue in the back row, but I want to get a message to Sue in the back row. So I'll say, can you just tell Sue this? Can you tell Sue this? Can you tell Sue? Can you tell Sue? Can you tell Sue? Can you tell Sue? And I tell everybody to tell Sue. Basically, everybody within my local communication range, I say, tell Sue this message, and then they pass it on to it. So when receiving a packet, every node rebroadcasts it just out to everybody it can see. You don't remember, you don't need to keep that message, you just broadcast it out again. And you end up flooding the network with this message trying to get to Sue. Eventually she only needs to get one of them, but then everybody else is a bit of a waste of time for it. Another route, another idea, source routing, where you sort of partially or completely specify the route. You might say, look, to get to Sue, can you just pass this message along the front row and then up the left-hand side and eventually get there? So you specify the route to get there. Another analogy might be, say, getting from point A to point B by road, either in a taxi or a car or something like that. If I want to get from Manchester to, say, I don't know how many people have ever been to Bolton, say, go from Manchester to Bolton, what's the best route? Some people might say, oh yeah, you go out through Salford, you get onto the East Lancs Road, you go up there, you end up on St Peter's Way, and then you travel down into Bolton. And that's the route to take. Or, no, I know a better route than that, that's always busy. You go through here, you go around through Lee, and then you leave and you go through some of these other ones. Now, that is the idea of specifying or partially specifying a route. And you get to a certain point on the network, and then somebody might redirect you. Like you decide that you're going to go down the East Lancs, you see a traffic jam ahead, you see that it's busy, and so you redirect through something else. Now these are different routing algorithms that your network can take. Or distance vectors. What's the shortest way of getting there? You might decide that, and the shortest being the shortest time. Not necessarily if you think about car driving, the shortest distance. The shortest time taken to get somewhere. You know that sometimes it's better to take one route than another because one route's always sort of jammed. So you ask neighbours to establish how busy things are as they're transmitting it. So these distance vectors work with your neighbours to say, well, I know how busy it is in here, you know how busy it is in things close to you. So I'll pass the message to you, you decide which way to go according to what that sort of route is. Now it's a bit hard to sort of figure in your mind until you sort of look at one of these in an example. So I'll just quickly flick to an example, concentrating on the flooding and source routing. So say in this sort of fairly trivial sensor network, we wanted to get something from A to H, the source to the destination, and the arrows indicate how far something can transmit. So A is only capable of transmitting to B or C, because that's just within its range. B is capable of transmitting to C, A, D and E. They're within its sort of range. So when A wants to get something to H, by flooding, it can just say, send this to H, will you? And C and B receive that, and then broadcast out to everybody that in distance of them, saying, send this to H. So A transmits it to B, B broadcasts that to D and E, D broadcasts that to G and E, presumably F might not be in range or whatever, and it's sort of going through. When C received it, it can broadcast it to B, but it's like, well, I've already sent that message. I've already received that from somebody else, so I'm not going to send it on. Again, I'm not going to rebroadcast. So you get a bit of intelligence in it. So if you've not seen it before, broadcast out. Otherwise, discard it. Now, eventually, by each one of these sending it out, you'll end up down at your destination if they're all transmitting it. It's like that old game about 7 degrees of Kevin Bacon. Have you sort of heard about that? It's about where you're related to Kevin Bacon by 7 steps, about who you know. Eventually you'll end up at anybody for it. So along the way, by broadcasting out all these know of others, and eventually this destination, each one is transmitting out. This destination says, well, this is the route that I got. So by flooding it, H knows the route that you took. So when it's sending a message back, it can just send it back FDBA, and send it back down and know where that route was to sort of get, you've established a route through that, so you don't need to flood it in future. You can just sort of use that route, unless it starts to take time, in which case you need to flood again to sort of get around. In source routing, let's bring that sort of thing up. Source routing, the same message going through, a bit more complicated this one, you can see by the number of annotations on there. You're attempting still to get from A to H for it. You put in a route request for it. So a route request to sort of get to H. And again, each one is passing on the route so far. So A broadcasts out its message to B and C. B remembers that it's just come from A, and so passes it on to D and says, I've just come from A to B. D passes it on to H and says, I've come from A to B to D to get here. Or passes it on to G, I've come from A to B to D. So each time, you're establishing what that route is as you're passing it on. So A's gone to C, passed it on to B and says, I've come through from A to C. And it says, I've got that already, so I'm going to forget about it.